You ever notice how a blueprint looks like it's full of promises it has no intention of keeping? I spent 3 hours yesterday stare fighting a set of isometric drawings for a pipe spool. It's like the engineer was trying to write a haiku using only straight lines and deceit.
Well, to be fair, Tiger, most things you call deceit are actually just your inability to read a tape measure past the quarter-inch mark.
Hey, I am a creature of precision when the spirit moves me. But fabrication, man, it's a different beast than just making stuff. It's a sequence. If you mess up the rhythm of the layout, you're just creating very expensive, very heavy scrap metal.
Today, we're getting into the weeds on fabrication layout and fitting. People use welding and fabrication like they're the same thing, but it's like saying baking is the same as running a five-star restaurant.
Exactly. Welding is just the handshake at the end of the deal. Fabrication is the whole negotiation. It's the design, the math you forgot from high school, the cutting, the bending, and, God help us, the fitting. If you can't fit it up, you can't weld it. You just end up trying to fill a half-inch gap with a MIG gun like you're decorating a cake with a fire hose.
God, I've seen those caulking welds. So, let's start at the beginning. If I'm looking at a raw stack of channel or a pile of Schedule 40 pipe, what's the first thing that goes through a real fabricator's head?
The first thing is the takeoff. See, in the world of piping particularly, a 90-degree elbow isn't just a 90. It has a radius. If you cut your pipe to the exact length of the run and then add the elbow, you're going to be 3 inches long and wondering why your assembly is trying to poke a hole through the shop wall.
So you have to subtract the fitting before you ever touch the saw?
Every single time, you're looking for the pup length. That's the actual piece of straight pipe between your fittings. You take your center-to-center measurement, say it's 20 inches, and then you have to deduct the takeoff for your elbows or your flanges. It's the kind of math that makes you pace around the shop talking to yourself.
I've seen you do that. I thought you were just looking for your glasses.
Those two. But the layout is where the ghost of your mistakes comes to haunt you. If you're building an architectural frame or a conveyor spool, you have to account for the thickness of the blade, the bevel of the weld, and the heat distortion. Heat is the thief in the night, Alex. It pulls and pushes. You clamp it down straight, you weld it, and suddenly your 90-degree corner is looking at you at an 88-degree angle, mocking your very existence.
Okay, but before we get to the screaming at the iron phase, walk me through the prep. I see these guys on weld tubes spending an eternity on the bevels. Why can't we just butt two pieces of steel together and let her rip?
Because an open root weld is all about the landing. If you just butt two flat edges together on thick material, the weld just sits on top like a scab. It doesn't penetrate. You've got to grind a bevel, usually about 37.5 degrees if you're being fancy, leaving a tiny flat spot called the root face or the land. It looks like a little cliff. You leave a gap between the two pieces about the width of a 1/8 inch electrode. That's your root gap.
So you're basically building a little canyon to fill with molten metal.
Exactly. And if that gap isn't uniform, you're in for a long day. If it's too tight, you can't get the heat in. If it's too wide, the metal just falls through and puddles on the floor, and you start reconsidering your career choices.
I've seen your reconsidering face. It usually involves a lot of staring at the ceiling. Let's talk about the fitting stage. This is where the magic, or the disaster, happens. You've got your pipe spool, your flanges, maybe a 45-degree offset. How do you keep it all square in 3 dimensions?
You become a devotee of the level and the square. When you're fitting a flange to a pipe, you're not just looking for it to be round. You have to two-hole it.
Two-hole it? Sounds like a Midwestern dance move.
Close. Most flanges have a bolt pattern. You put a level across 2 of the top holes. If those 2 holes aren't perfectly horizontal, the guy in the field who has to bolt this thing to a pump is going to be calling you names that would make a sailor blush. You have to ensure that fitting is plumb, square, and level all at once. I once spent 40 minutes tapping a 6-inch flange with a brass hammer, moving it a hair at a time until it was so perfect I almost didn't want to weld it.
Tap, 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 and then you hit it with a massive arc of electricity and hope it doesn't move?
That's where the tack weld comes in, but you don't just blast it. You bridge the gap. You put a small, strong tack at the top, check for square, tack at the bottom, check for square. If the metal starts to pull, and it will, you use the heat to your advantage. You tack the side that's too open and let the cooling metal pull it into alignment. It's like wrestling a bear that gets smaller as it gets colder.
See, this is what the manuals don't say, that the metal is actually alive. It's moving.
Oh, it's a living thing, and it's grumpy.
You mentioned CAD earlier. We're moving into 2026. Is the old way of soapstone and a framing square dead? Are we all just feeding things into robotic arms now?
Robots are great for doing the same thing 10,000 times. If you're building 5,000 retail fixtures for a boutique chain, yeah, you want a robotic welder because it doesn't get hungry or bored. But for the custom stuff, the structural beams for a weird-shaped house, or a one-off industrial conveyor, you need the human eye.
Because the floor isn't level and the walls aren't square.
Exactly. A robot assumes the world is perfect, a fabricator assumes the world is a disaster, and builds accordingly.
That might be the most tiger thing you've ever said.
Well, it's true. Even with CNC plasma cutting and laser alignment, you still have to fit the parts. You get a piece of plate that's slightly bowed, or a tube that's a fraction of a millimeter out of round. You have to know how to use a dog and wedge to force that steel to mind its manners.
Wait, explain a dog and wedge for the people who don't spend their weekends covered in slag.
It's the simplest tool in the world. You weld a little scrap piece of L-shaped steel, the dog, to your work surface or the main member. Then you drive a steel wedge between the dog and the piece you're trying to move. It's an incredible amount of leverage. You can move a 1-ton beam with a hammer and a wedge if you know where to place it. It's about making the metal submit to the layout.
It sounds a bit like structural bullying.
It's firm negotiation.
Let's pivot to the different flavors of fabrication. You've worked on industrial spools, but you've also done some of those high-end retail fixtures, the silent workhorses, as one of our sources calls them. Is the mindset different when the weld is going to be visible in a fancy store versus buried in an oil refinery?
Man, the pressure is different. In a refinery, that weld is getting x-rayed. If there's a tiny speck of slag the size of a grain of sand inside the metal, they'll cut it out and make you do it again. It's about internal integrity.
And the retail stuff?
That's about looking designed. You're often using TIG, tungsten inert gas, because it's clean, no splatter. You want that stack of dimes look. But here's the secret. Sometimes the finishing stage is the hardest part of fabrication. Grinding a weld flush so it looks like the two pieces of metal grew together organically, that's an art form. You can hide a lot of sins with a flap disc, but a real fabricator knows that if you rely on the grinder, you're just a grinder with a welding problem.
Ouch, I felt that one in my soul.
I say it because I've lived it. I remember building this custom display rack. I was rushing, the fit up was sloppy, and I thought, hey, I'll just fill the gap with wire and grind it smooth. I spent 4 hours grinding. 4. By the time I was done, I'd thinned the base metal so much the whole thing was structurally about as strong as a wet noodle. I had to scrap the whole thing and start over.
That's the tuition you always— Oh wait, you told me not to say that.
You caught yourself, but yeah, that was a heavy day. The lesson was 3 minutes of better fitting saves 3 hours of miserable grinding.
Let's talk about the blueprints. For someone just getting into fabrication, those isometric drawings, the ones that look 3D but are on a flat 2D page, can be a total brain breaker. What's the trick to seeing the pipe in your head?
You have to follow the flow. Most isometrics have these little arrows, and you look for the north arrow on the page. I tell people to actually physically orient themselves in the shop. If the drawing says the pipe goes north, you point your pipe toward the back wall. If it turns east, you turn it toward the coffee machine.
So the coffee machine is east. Got it.
It's the only way to keep your head on straight. And you have to watch those rolling offsets. That's where the pipe doesn't just go up and over. It goes up, over, and slightly to the left at an angle. That's when you start breaking out the Pythagorean theorem.
A squared plus b squared equals tiger's head hurting.
Exactly. You're calculating the diagonal length of a pipe that's moving in 3 dimensions at once. If you get that length wrong by half an inch, by the time that pipe run reaches the other side of the building, you're 3 feet off target.
It's all about the takeoff again.
Every single time.
We've talked a lot about steel and pipe, but the modern shop is using a lot more than that. We've got exotic alloys, aluminum, stainless. Does the layout change when the material gets picky?
Oh man, stainless steel is a whole different ballgame. It expands and contracts like it's breathing. If you weld one side of a stainless frame, the other side will move so far it'll practically be in the next zip code. You have to backstep your welds. You weld a little here, move to the opposite side, weld a little there. You're constantly chasing the heat to keep the piece from warping into a pretzel.
And aluminum?
Aluminum is like welding a popsicle with a blowtorch. You have to be fast, and your fit up has to be absolutely airtight. There's no filling a gap in aluminum fabrication. You either have a perfect fit or you have a hole.
Helpful advice: don't have a hole.
I'm a font of wisdom, Alex.
Okay, let's wrap this up for the folks at home. If someone is standing in their garage shop right now looking at a project, what's the one thing they should do differently on their next layout and fit session?
Burn an inch.
Burn an inch?
Yeah. When you're using a tape measure, don't hook the end of the tape over the edge of the metal. That little metal hook on the end of the tape is always a little loose. It's supposed to be to account for its own thickness, but it's a source of error.
So you start at the 1-inch mark instead?
Start at the 1-inch mark. Hold it flush, mark your spot, and then, for the love of all that is holy, don't forget to subtract that inch from your final number. I've built a lot of things that were exactly 1 inch too short because I got distracted by a shiny object or a cool bird outside the window.
The Tiger Special.
Hey, it happens to the best of us. But the real takeaway is this. Fabrication is a game of patience played with very stubborn materials. The time you spend with the soapstone, the square, and the calculator isn't pre-work. It's the work. The welding, that's just the victory lap.
I like that. The welding is the victory lap.
Just make sure you don't trip on the way to the finish line by rushing the fit up.
Wise words from the man who once welded his own glove to a work table.
We said we weren't going to talk about the glove, Alex.
Next time, folks, we're talking about safety gear, specifically how to avoid becoming part of your own project.
See you in the shop.